Reinforced concrete beam, bending or flexural member. Beam is a horizontal structural member, whose length is large relatively in comparison with its thickness and depth, that is capable of withstanding transverse loads primarily by bending. Beam generally carry vertical gravitational forces but can also be used to carry horizontal loads, that is loads due to wind or earthquake. Load carried by beam are transferred to columns, walls, or girders which then transfer the load to foundation. Types of beams. Based on support condition it can classified as simply supported beam, continuous beam, cantilever beam, fixed beam. Based on geometry and loading it can classified as main beams, secondary beams, deep beams, dap beams, upstand beams. Based on construction it can classified as in situ beam, precast beam, pre-stressed and post-tensioned beam. Beam shear reinforcement. Shear links in beam shall pass around or adequately secured to outermost tension and compression reinforcement with proper anchorage. Shear reinforcement should be at an angle of 45 to 90 degrees to the centroidal axis of the member. It may comprise a combination of the following types of reinforcement. 1. Stirrups enclosing longitudinal tensile reinforcement and the compression zone. 2. Bent-up bars. Torsion reinforcement. Torsion refers to twisting of structural member loaded by twisting forces. Crack patterns under pure torsion are shown in the figure. Along with torsion, beam is also subjected to flexure and shear. Stresses induced by torsion are resisted with closed stirrups and longitudinal reinforcement along the sides of the beam. The distribution of torsion along a beam is usually same as shear distribution, resulting in closely spaced stirrups. Opening in beam. Openings in beams becomes necessary to provide service lines like water supply lines, air conditioning ducts, etc. Circular holes are preferable as square and rectangular holes can induce stress concentrations around the corners, increasing the risk of cracking. Additional reinforcement for beam openings. Horizontal flexure steel to resist moment and for anchorage of stirrups. Diagonal bars are essential for achieving crack control. Vertical stirrups to resist shear near both sides of openings. Thank you. For more videos please subscribe Feel Free Creations Rebar Details.